continue with the next item where we'll be discussing about how we can revert the changes or undo the changes from the local repository. And then we'll get into our Git branching strategies. And finally, we'll be focusing on the remote repository handling. Next, we'll see how to undo the changes from the local repository. Okay, like consider I have a repository where I have committed some changes into the local repository. So if you want to undo the changes from the staging area, we have used a command called git rm command. Using git rm command, we can able to undo the changes. That is, unstage the changes from the staging area, and whether you want to take the changes back to the working directory or you want to permanently remove it. Based upon that, we have performed this -cache option or RF. Now the point is we have made some changes in the local repository, and from there we want to undo the changes. So how we can able to perform this activity? So now we'll see how to create a repository, make some changes and commit the changes to the local repository. And once things are ready, we can able to undo those changes. So before you actually talk about these things, right? So we need to understand some basic CLI commands. So in order to perform undo action on any committed changes, Git provides two important functionalities. One we call it as Git Reset and another command is Git Revert. So these are two important, very important commands that is used to undo the changes from the repository. Let's say, for example, when I say head pointer, so head point always points to the latest commit of your current branch which you are in. So consider I have a repository where I made the very first commit. So when we make the very first commit, the head pointer will be pointing to that commit point. So whenever I make any new commits, the head pointer will be moving towards the latest commit. So this is my commit 4. This is the latest commit, and this head is pointing to latest commit of the current branch now. While reverting the changes, it is not about taking the data back. It is also a matter of moving the head pointer back to the previous position. Correct? So that is the reason we use head pointers. Apart from this, so consider in my local machine, I have a working directory where I have a file created. So when I use git add command, what happens? The changes whatever we have created will be added to staging area, correct? And when I issue git commit, the same file whatever we have in the staging area, it will be permanently committed to the local repository. So assume that your repository is already having 2 commits. Now when you add a new commit here, it will create one new commit point. And not only that, the head pointer will be moving towards the latest one now. So from commit 2, the head pointer will be moving towards it. So when you issue any commit command, there are 2 things happening. One is it will create a new commit point, and also the head pointer will be pointing to the new commit point. Easy? The point is this file has been updated to my local repository. It has created one new commit ID and the head is pointing to this new commit point now. So now if I want to undo the changes, if I want to undo this, there are 3 possibilities. Either I can take the changes back to my staging area, or I can take it back to the working directory, or I can able to permanently remove those changes from my system. So these are 3 important possibilities. So if your intention is just to undo the changes, take the changes back to the staging area or working directory, or if you want to permanently remove, we'll be using a concept called Git Reset. So Git Reset is used to undo the changes from the local repository. And I'll talk about Git Reset in detail, but as of now, on a high level, you can understand it is just to undo the changes from the local repository. So when you say undo the changes from local repository, what is the intention? Whether you want to take the changes back to the staging area, or whether you want to take it back to the working directory, or remove it from the local repository as well as from the working directory. So based upon these scenarios only, your reset action will be functioning basically. So there are 3 different types of reset option. Based upon your requirement, you can able to use any of these options. First, let's talk about the Git Reset in detail, and then I'll be coming back to each and every type of reset now. So when we say Git Reset, ultimately this Git Reset is used to undo the changes from the repository, I told you. And apart from this, it is also going to reset the commit point to the previous commit. Let's say I have 4 commits here. This is my latest commit. So my requirement is I want to reset back to my previous commit. So what happens now? The head pointer, which is pointing to 4th commit, should be moved to the previous level. That's what it is. Git reset will reset the commit point to the previous commit point. And it will not create any new commit point for tracking purpose. As part of Git is concerned, whenever we perform any action on this Git repository, we can able to track those changes, right? But when you use Git Reset, there is no capability to track those changes because it will not create any new commit point for tracking purpose. So because of this reason, it is not recommended to use Git reset in the shared repository. For example, consider I have a repository which is being used by multiple users in a real-time environment, like user A, B, and C. There are 3 users working on this repository, means they are allowed to update any number of changes in the repository. Now, without proper knowledge, if you try to reset any of these changes, means it will impact the entire integrity of your repository. So that is the reason it is not recommended to use Git reset in the shared repository. If you're sure about what you're doing, you can use Git reset. Otherwise, don't try to use Git reset because it will not create a new commit point for tracking purpose. We'll be losing a track of changes. I'll show you with an example also now. And this is a general syntax to implement Git reset. Git reset followed by the reset option. So what all the reset option means? We have something called Git Reset Soft option, Git Reset Mixed, and Git Reset Hard option. So these are all 3 options that is required. So what is the need for Git Reset Soft means? It is used to undo the changes. It just takes the changes back to your staging area. It means if you want to undo the changes, the committed changes, whatever you made in the repository, if you want to take it back to the staging area, in the case you'll be using Git Reset Soft option. So what will happen means it will remove that entry from the commit history, and that commit, latest commit will be removed. The control head pointer will be pointing back to the previous commit, what are we mentioning. This is Git Reset Soft. If your intention is to take the changes back to the working directory, you can use Git Reset Mixed option. So when I say Git Reset Mixed, it will move the head pointer back to the previous commit point by removing the current commit, whatever you made, and the file, whatever you maintain in that Git repository, it will be removed from the repository, as well as it won't be having anything on the staging area, but the file will be available in the working directory. It is also a safest way. But if you use Git Reset's hard option, means the file, whatever you committed in the local repository, it will be permanently removed from the staging area as well as from the working directory. It is a permanent loss of data. So it will take the control head pointer back to the previous commit, as well as it removes that file permanently from the repository. That is about Git Reset Hard option. So when I say Git Reset Soft, it will reset the head pointer to the previous commit point, and it will take the changes back to the staging area. From the local repository, changes will back to staging area, and the changes will be available in staging area and the working directory. That matters. Means the changes, whatever we maintain in the local repository, it will be removed, but you can able to access it from the staging area as well as from the working directory. That is about Git Reset Soft option. Whether you're using Git Reset Soft, Mixed, or Hard option, it will not create any new commit point for tracking purpose. Okay, please keep this point in mind. It is common for all these types. And when I say Git Reset Mixed option, it will reset the head pointer back to the previous commit point, and it will take the changes back to the working directory. Local repository, the change will be moved back to the working directory. So that is the difference, basic difference between your Git Soft and Mixed option. When I say Git Reset Soft option, it takes things back to staging area, but here it will take to working directory. It means the changes, whatever we made, it will be available only in the working directory. Now, when it comes to the Git Reset Hard option, it will just reset the head pointer to the previous commit, as well as it will permanently delete the files from the file system. That is a basic difference. And out of these 3 options, Git Reset Mixed is a default option. All right. So let's say I have accidentally made some changes, accidentally committed something. I just want to remove it from my local repository as well as from staging area. Means I can simply use Git Reset Mixed. That commit point will be removed from that repository. Change will be back to the working directory. But you want to take the changes back to the staging area for some reason. You're not going to commit it. Actually, you just want to make it a staging area. Means you can simply use Git Reset option. So reset option mostly we never prefer. We have the capability, but still in real-time environment, there is no use of this thing. Because whenever we make any changes in the staging area, our intention to commit the changes. Upon commit, if you want to revert, means either you can take it back to your working directory or you can able to remove that matters. And sometimes we'll be using Git Reset Hard option. This is completely to reset your repository. It will never maintain any other entries over there. What are changes you made, everything will be permanently removed from there. Let's say, for example, consider I'm going to create one repository now. So this is just a folder we have created here. And what is the command to initialize this? Init. Now, once it is initialized, I can make some commits here. commit in the sense like I can create a new file and I can able to add it to the staging area of this master branch, and I can able to commit these changes. I can just simply tag it as CM1 for now. Just a message, CM1, commit message 1. Now, once I commit the changes, we just made a very first commit here. Okay, so like this, I'll add few more commits, okay, for sake of demo. So like this, we made few commits in the repository. So these changes can be done by anyone. If it is a shared repository or if it is your own repository, it will be done by the individual user. Now, my requirement is I want to take the changes back. Okay, I just want to reset the commit, whatever I made. So what can I do? First, I can able to use Git Reset Soft option followed by the previous commit ID. So before that, if you say ls, you should be able to see these files are available in my working directory. As well as if I say git ls-files, I can able to see the files are being tracked by Git. And when I say Git status, working tree is clean because there is no uncommitted changes are here. Now let's reset using soft option followed by the previous commit ID. A05475 is the previous commit ID. So from CM5, I want to take the control back to my CM4. I want to remove what are things I made in my CM5. So if I run this command and if I say git status, the changes whatever we made in the local repository has been taken back to staging area. That is a file f5.txt has been taken back to staging area, and we are getting this message. It means there is some changes available in staging area now. And if I say ls, I can able to see the file in the working directory. And also if I say git ls-files, the changes are available in the Git also. Git is actually tracking the file because it is in the staging area now. But when I say git log one line, you can see that commit whatever we made has been completely removed from the commit history. So your git reset will not create any new commit point for tracking purpose. It just reset the commit point to the previous commit. That's it. So here this is considered as a safest, very safest, but minimal used feature. Changes can be moved to staging area. All right, that is about Git Reset Soft. Let me take it back. Git commit -m CM 5.1 for now. So I just taken changes back to local repository now. Now if I say git log one line, I get a new commit point. And if I say ls or git ls-files, I should able to see those files available there. And also if I say git status, my working tree is clean now. Now let's go ahead and perform git reset using mixed option followed by the previous commit ID. Here also I'm going to give the same previous CM4's commit ID. And if I say git status, what is the expectation here? Mixed option will take the changes back to the working directory, correct? So here that file f5 should be considered as a untracked file because this git reset mixed option will take the changes back to the working directory. So it means when I say ls, I should be able to see the file available in the working directory. But when I say git ls-files, it won't be there because it has been completely removed from that staging area as well as from the local repository. And if I say git log one line command, you can see it has removed the commit history. So now if you want to take the changes back, what you can do, you can use git add and git commit -m CM 5.2, something like this. That's it. Now the status should be clean and ls should find the file in the working directory as well as git ls should get me the files from the repository. And the git log command should get me the latest commit which I made now. Easy. So at any point of time, if you want to take the changes back to the working directory, you can use your git reset mixed option. But sometimes what happens, we no need this particular case. What are the commits I made? I just want to permanently remove the changes. So in the case, I can simply use git reset -f hard followed by the previous commit ID. So when I say git reset hard option, the head pointer will be moving back to the previous commit from CM5.2, it will go back to CM4. And the changes, whatever we made in CM 5.2, it will be permanently removed. It's a permanent deletion. So when I say git ls-files, it won't be available. F5 has been removed from the repository as well as from the working directory. And the git status should be clean. And when I say git log one line, I can see CM 5.2 has been removed permanently from the history. So it is not just about the previous commit, okay? Like for example, if I say git reset hard for any option, you can able to use any of the previous commit. Let's say if instead of CM3 now, if I give CM2, so from CM4, CM2, CM4. So that is what the reset actually. So now if I say git log, I can see only two commits, CM1 and CM2. Similarly, if I say git reset hard option, and if I say the initial commit, it is removed. So if I say ls, there is only one file that we created for CM1, and git ls-files should give me the file that is available in the initial commit. So now if anyone look into the repository, let's say I am a reviewer, I just want to review my repository. And if I simply say git log one line, what I can understand from this, we made a lot of things in the repository. We have made, initially we made 5 commits, and then we have performed git reset soft option. And again, we committed it. We made git reset mixed option, reset hard options 3 times, but there is no trace of all those things, right? So that is what. So git reset will not create any new commit point for tracking purpose. And git reset is not recommended in the shared repository. That's the reason, because if you see, there is no track of it. If it is a shared repository and by accidentally, if you try to make any changes, it impact the entire flow of repository. We cannot use your commit, remove commit ID. Okay, commit ID is mandatory. Whenever you want to give git reset, commit ID is mandatory, but option can be anything. You can simply say git reset followed by the commit ID. If I say git reset followed by the previous commit ID, what will happen means it will execute the git reset mixed option because it is the default one. But commit ID is mandatory. So now in which scenario we are going to use it means, let's say for an example, consider in real-time scenarios, right? We'll be working on some sort of ETL process and all, like extraction, transmission, and loading the data to other database and the kind of thing. So consider I want to extract the data from one upstream system. From this system, I want to extract the data. The data, whatever I'm going to extract, will be like a raw data. Okay. It can be from the monitoring tool or any other logger tool or reporting tool. I just want to extract this data. It is a raw data, whatever I'm going to extract. I just want to maintain a repository, Git repo. So it has created one new commit point here. This is my initial commit of the repository. And this is the first commit which we made for this data extraction. So once the data is extracted, if you want to process the data and store a database, then we'll be using another method called loading. That's what extract, transform, and then load, ETL process. So this data, whatever you extracted, it can be loaded to your database with proper relational data in the form of tables, rows, and columns. So once the data is processed and loaded to the database, do you still need that entry in the repository? Let's say I'm trying to extract the hourly transactions of a stock market or the ATM transactions. It's just for reporting purpose. Or I just want to take the log of all my ATM transactions. So the log, whatever getting generated in the system, I want to extract and maintain in my repository because just a junk data. And from there, I can able to process the data and store it in database. Only processed data can be stored in database. Till the time, data will be available in repository. Once we process and permanently store in database, do you still need the entry? Not required. So if the entry is not required, I'm not going to delete that repository. Why? Because I'm going to do this activity for every 1 hour. For every 1 hour, the data will be extracted in the repository and will be loaded to the database. So once it is loaded to the database, this entry, whatever I made here, I can simply use git reset hard and remove the entry permanently. So that repository will be reset to the previous or initial commit. And then again, the process starts, it add a new commit here, and this will be again transformed and loaded. So for such situations, if you're sure about what you're doing, you can use a git reset option. And the limitation git reset is we cannot reset to any specific commit point. Let's say you have 5 commits. If you want to remove one particular commit in between, it's not possible. It just reset to the previous commit only. So how we can able to achieve that? Out of 5, if I just want to undo only one particular change means, in that case, we cannot use git reset. We'll be using git revert there. Now, without impacting the commit history, how I can able to undo the changes. For that, we can use Git Revert action. And it is very much recommended even in shared repository. So these are the pointers you need to remember when it comes to Git Revert. So this Git Revert, it is also same as the Git Reset Hard option. When we say Git Reset Hard, it is going to permanently remove that entry, right? Similarly, the Git Revert also will permanently remove the entry whenever you use Git Revert. But difference is Git Revert is used to undo a specific commit point. Out of 5, if you want to remove one specific commit, you can able to remove by using Git Revert. But in Git Reset, it's not possible. And Git Revert can create new commit point for tracking purpose. Whenever you make any changes in the repository by using Git Revert, you'll be getting one new commit ID there, which can be used for tracking the changes. So without impacting the commit history, if you want to safely undo the changes, you can use Git Revert. And that is the reason it is recommended in the shared repository. So let me make some changes here. Okay, let me create a file. I'm going to make few more commits. So we made these 5 commits in the repository with these 5 files, and Git is actually tracking these files. Now, the point is the Git status is clean, and I want to revert changes. So if I say Git revert, followed by the previous commit ID. So previous commit means I just want to undo this particular commit alone. It is not like resetting to that level. I just want to undo that particular commit. So just simply say Git revert followed by the commit ID. So when you say Git revert, see, it was waiting for the commit and it is expecting a commit message. Why? Because this Git revert will create a new commit point. To create a new commit point, it requires a commit message. That's why it is expecting commit message, and this is a default commit message generated here. If you're okay with this commit message, just save the file, escape:_wq. It's a VI editor, just save the file. That's it. So now a new commit has been created. If I say git log one line, you can see a new commit point has been created that defines revert cm4. And if I say ls, the file whatever we have created in cm4 has been removed. Because as part of cm4, we have created s4.txt. Remember that commit file whatever we created in that commit has been removed permanently. Git ls -files, you can see it is not having the entry. Easy. So as like Git Reset Hard option, Git Revert also going to permanently delete the file from the working directory as well as from the Git. But only difference is we have a capability to track those changes. We have a new commit ID created to perform that activity. So if I use git show command, let's say I'm just reviewing these changes and I just want to know what exactly happened in this repost, this commit. So I can able to understand that there is some changes happened. It has reverted the changes and it has deleted the file which we made in the particular entry. So if I see like it is an accidental commit or accidental removal, I can use git revert followed by the same commit ID. So what I'm going to do now? I just want to recover changes. That's what the point. So that this capability is available only with your git revert action. So through this commit ID, we can able to revert it. Again, it will ask for the commit message to reapply the changes. If you're okay with this, save this message. That's it. Now, if I say ls, I should be able to get the changes back. So git revert is considered as the safest way to undo the changes. So now if anyone look into the repository by checking the log, you can quickly understand, okay, it is not impacting the commit history. The commit history is in linear fashion. There is no impact in the history. So anyone who looks into the repository can clearly understand what exactly happened in this. Initially, we made 5 commits and here we have reverted this CM4 and again we reapplied CM4. So this is what expected in your shared repository. And that is the reason we recommend git revert in the shared repositories. Once the files are removed, it is a permanent removal. We cannot recover it by default. So if you want to safely undo the changes, it is recommended to use your git revert. So the next topic in the list is about gitignore file. So basically this .gitignore file is used to maintain, okay, or is used to ignore the files from tracking. That's it. Very simple. Whenever we create any file in the working directory, Git will automatically start to track the file. But if your intention is to ignore it, if you don't want Git to track the changes, you can simply use those file names in the .gitignore file. So this .gitignore file is a hidden file used to maintain the file names or patterns to be ignored by Git. Simple, right? And as a best practice, .git ignore should be the very first commit. As a best practice, we always recommend to have .git ignore as a very first commit. So what is a real-time scenario? What is a real-time use case for this means? So let's say, for example, consider as a developer, I'm trying to create one project, my application project. It can be my Java web application project. Okay. So when we create any such project, right, this folder can be considered as a project workspace folder, which can have some components. Source itself, I can have something called main with Java programs, and I can able to use some test folder for maintaining test cases. That is also a Java component. And resources, it can have some HTML files or any CSS files. And also I can have some application properties files will be there. And if this application is of 3-tier application, and if the user wants to interact with the database, and if they need credentials, the credentials also can be maintained in a separate file like DB credentials or DB password or secrets. Okay. So like this, we'll be maintaining n number of project related components in this folder. Now, not only this, as part of my project, there'll be something called a target folder. In this target folder, the application artifacts, the artifacts, the binaries, whatever we create as part of the build, this binaries will be created and maintained here. Say, for example, when I create any Java program, my intention is to version control the source code changes. That is what the purpose of any version control system. Once I create this source code and perform build, it creates the artifacts. So do we try to version control the artifacts here? Means no. Git is not actually meant for version control the artifacts here. We never keep anything on the Git repository related to your artifacts. We only maintain the source code changes. So if that is the case, I don't want Git to track my target folder. I don't want Git to track the war files, whatever I create. I don't want to version control it. So at any point of time, if you don't want to track any of these files from this folder, you can add that file name in the .gitignore and Git will simply ignore it. Let me show you that once. Let's get out of this folder and we'll create a new folder here. Let it be. Let me initialize this. So now this is a repository which we just initialized. And as I said already, it is always a best practice to have the initial commit as .gitignore. So what I can do here, I can simply create a file, or I can use a VI editor. VI followed by the file name .gitignore. The file name should be exactly same. It should be prefixed with dot, and it should be in small case. So if I say ls or ls-a, you can see only the hidden files and folders. So the file what I'm going to create here, it should be an hidden file that is being used by Git. So vi followed by .gitignore and go to insert mode and enter the file names. Like what are files you want to ignore? Like I want to ignore sample.txt file. I want to ignore temp.doc, or I want to ignore all the empty files. I want to ignore all the jar files, or I just want to ignore the entire target folder. So if you want to use or ignore the entire folder, you can use a folder name followed by that // If you want, you can give a complete file name, or you can give some file patterns like this using wildcard symbol. So it means I just want to ignore all the MD and jar files here. So as part of your application design, okay, while creating the repository, it is a responsibility of the application architects, the application owners, who's responsible to maintain the repository, who's owning the repository. It is their responsibility to maintain these entries as the first commit. Now, once changes are ready, simply save this file. And if I say git status, we have to commit this. So just give git add and say git commit -m, and I just want to maintain this is my initial commit for .gitignore. That's it. Now, if I say ls, I won't find anything because it is a hidden file. Use ls-a and checked out. So now your repository is ready for your application components. So once you have gitignore file, and if you try to make any commit, right, or not only commit, even if you check the status, in that case, first it will verify the gitignore file. If there any changes available as per that file name, it won't consider that file at all. Let's say in this file, I have these 4 or 5 entries. Now my requirement is I want to create a new commit. Go record one. Let it be like file1.txt. And when I say git status, you can see that file1.txt is getting considered as untracked file. Now, if I create another file like git record one sample.txt, and if I say git status, see that sample1.txt, which is present in the working directory, it is not being considered by Git when I say git status. We just created it, but still Git is not considering the file for tracking because that entry file name is available here. So whenever you had any file name in the git ignore, based upon that file name, Git will not consider for tracking purpose. So when Git is not tracking the changes, you cannot add that file to staging area, and you cannot add it to working in a local repository as well. Consider the same repository here. I have this repository, and in this particular folder, project folder, I have some database credentials. The user's credentials are there to access the database. Without proper knowledge, if I add all this thing to my staging area, and if I commit to the local repository, and if I push it to the remote repository, what will happen then? So the entire credentials, it is getting exposed to remote repository. So if you don't want to share anything, if you don't want Git to track these changes, because these changes are meant within the local user's machine, in that case, the file can be ignored by Git. So like this, on this repository, we can able to make any number of changes. Let's say, let me add it to staging area and commit it to my local repository. And I can able to make any number of file changes here. Commit and what else? CM2 like this. So now if I say git status, I can see working test screen. If I say git log, I have these 3 commits. And if I say ls and ls-a and git ls-files, I have these many entries. Now I want to reset my repository completely. So what I can do, I can simply say git reset followed by the very initial commit ID using git reset hard option. So what will happen now? It will remove all the changes from this repository, whatever we made from CM1, and it just maintains only one commit with that git ignore. So this is the actual purpose of git reset, okay? Git ls-files. So ultimately, this repository has been reset to the initial commit. The initial commit is not related to my project component. It does not have any program files. It is just having a git ignore file. So for all your ETL related process, or if you want to completely reset your repository, this is the best practice. So the next topic in the list is about Git branching techniques. So ultimately, these branching techniques are used to perform the parallel development in Git. So any repository that you create using Git, it is based upon branches. By default, it creates a master branch, and based upon that, it can able to create your feature branches and do some parallel development. So when we talk about the branches here, so in any distributed version control system, the branches are used to perform the parallel development. And when you create a repository, we can find one default branch called master, which is considered as a production version of your source code. So tomorrow, if you want to share your work to any other developers or any other external or downstream applications, we'll be considering this default branch. And even for production implementation also, the change will be moved from the master branch only. So while doing the parallel development, we have to maintain the integrity of a master branch. That is very much important. Correctness of data. Whatever you commit in the master branch should be committed with proper testing and reviews. As like that, you should not create any commit points here. As like that, you cannot dump the content to the master branch because it is going to be directly referred in the target environment. So how we can able to maintain the integrator of master branch means, for that we need to learn something about the Git branching strategies. So this Git branching strategies are used to maintain the integrity of master branch. Simple. So this is what the objective. So to achieve this, you can do anything you want. So people who are working on distributed version control system, they should be very strong in implementing this strategy. So how to implement means there are various scenarios to implement this. Let's take for an example, consider I have a repository like, and when I create a repository, what we get a default master branch. And in this master branch, you need to create a number of commits like CM1, we just made, right? CM1, CM2 or CM3. I can able to make any number of commits in the repository master branch. And if I want to work on that feature, or if I want to work on this particular project, I can able to use something called a feature branch, feature one. So feature one is another branch. It can be created based on master branch. So it means it is just a replica of master here. What are all the commits you made in master branch? It just inherits its properties and creates the new branch. And in this new branch, you can able to make your own commits. Feature one's CM1, feature one's CM2, feature one CM3. Like this, we can able to make some incremental changes in this feature one. Correct. And once the changes are ready, it can be merged into the master branch like this. So why we follow this approach means currently this master branch is having 3 commits, which is being used by more than one users in real-time environment. It is being shared. And on top of it, if you try to make any changes, it will definitely impact the master branch. So what I can do here, I can create one feature branch, which is just a logical copy of a master branch. Master branch means it is a default branch and feature branch is a logical copy of the master branch. Once we have that feature branch available, you can able to make any changes in feature branch. It will not impact the master branch until you merge it. Ultimately, I want to maintain my source code changes and I want to perform some independent development. Okay, whenever I make any changes in the repository, it should not impact the current workflow of the repository. It should not impact the integrity of master branch. So for that, what I can do here is I can create a strategy, and through the strategy, I can create one temporary branch called feature branch. And with that feature branch, I can able to perform a number of changes. Once the changes are ready, I can able to merge it to my master branch. So with this, I can able to independently do the development. So consider a scenario. I am an independent developer where I'm the only person working in this project. So if that is the case, if I want to work on any of these changes, I can able to directly implement it. Consider a scenario. In this scenario one, I have a repository, and in that repository, we have a master branch with initial or 2 or 3 commits in general. So assume that I'm an independent developer. I'm the only person working on this project. So in my local machine, what all changes I want to make, I want to version control it. So if no other features I want to work, if I have only one feature means I can directly use my master branch and creating a number of changes. There's no issues. But if I want to independently work on it, already master branch is having some source code. I don't want to disturb the existing code. For my new functionalities, I can create one new feature branch. And whenever I create new feature branch, it is just a copy of it, master branch. So here I can able to make some incremental changes and start working on it. This is one scenario. So this is also not an actual parallel development. In this scenario one, we are not doing any parallel development. Already I have a code in master branch. I don't disturb the code. So I have prepared a separate branch and I'm making some incremental changes. Once my changes are ready, upon proper review and testing, I can merge it to my master branch like this. This is very basic scenario anyone will follow while working on the project. In case if more than one developer are working on the same repository at the same time for the same release, in such situations, what we can do means we can able to opt for the scenario 2. So in scenario 2, what I'm going to do means I'm going to use the same repository, but here the point is we'll be creating 2 branches, that is feature 1 and feature 2. And both feature 1 and feature 2 are based upon master branch. That's why we have the commits replica of master branch as it is. Now, in this feature 1, I am allowed to make any number of commits here. Similarly, in feature 2 also, I can able to make some number of commits. Feature 2's commit 1, commit 2, and commit 3. once the changes are ready, we can able to merge these changes into the master branch like this upon merging feature 1. So the point here is the feature branches are considered as a short-lived branch. Once you merge changes into the target branch, the feature branch can be deleted permanently. It is no longer required. And ensure that before you commit or merge your changes from feature branch to master branch, you have to do a thorough testing on your changes, incremental changes, as well as it should be done with a proper review. Only then it can be merged. Now, in this case, we are trying to work on two different features. It can be a same developer or multiple developer, doesn't matter. We are working on two features independently without impacting master branch. Upon proper review, we're just taking changes back to the master branch. So now, if my feature 2 is ready, I can able to update it here also, feature 2. So this is what the logic behind scenario 2. And this scenario 2 is applicable for individual developer. Let's say I'm the only developer working on the project and I'm working on multiple features at the same time. I can able to use this scenario. What if I have one more developer joins a team? Let's say, this is meant for a single developer. In such scenarios, while working on multiple features, can we expect the integrity of a master branch? Because more than one feature or more than one developer can able to work on the same file. And without proper review, if you try to update means, it will definitely impact the integrity of a master branch. So whenever you're working on multiple features, it is not recommended to directly update the features to your master branch. In that case, the scenario will be extended like this. The best practice, what we follow here is, instead of directly creating a feature branch, we first create a dev branch. And this developer branch will be the copy of your master branch by default. Okay, so based upon master branch, we are going to create developer branch in scenario 3. And based upon the developer branch only, we are going to create these feature branches. So in scenario 3, instead of directly creating the feature branch from the master, we are going to create one developer branch, and this developer branch is a copy of a master branch now. And based on the developer branch, I can create a number of feature branches. Why we go with this approach means, in scenario 2, developer can able to create a number of features, and if they try to merge both their features into the master branch, it will create an impact. There might be some merge conflict happens in this master branch. Chances are there, right? More than one feature can update the same file in the target branch. So definitely there will be a chance of getting the merge conflict. So to overcome this, what we do means, we are creating one intermediate branch for that particular developer. And what all the features the developer creates, it can be thoroughly tested locally. And once the changes are ready, the changes from the feature 1, it will be merged into a dev branch first. This is upon developer feature branch 1. Similarly, once the feature 2 is ready, they can able to merge these changes on top of this branch here. So this is upon merging feature 2. So now the point is, I have updated what all changes I made in my feature 1 and 2. I have updated those changes in the dev branch. If there is any conflict occurs also, it is going to impact the dev branch only. And if any conflict occurs, I can able to fix the conflict, and upon thorough testing, I can able to merge these changes into the master branch. Because as per the branching strategy, my intention is to maintain the integrity of a master branch. If I allow the features to directly update the master branch, it will definitely create an impact. It will create a merge conflict in the master branch. So to prevent the conflicts in the master branch, I have introduced one developer branch. And here we can able to allow any number of features to be updated in develop branch, and upon thorough review and testing, you can merge it to master branch, which will not create any impact there. Easy. So now once you merge, it can be something like this. Like, we are expecting the conflict in the target branch all the time, but the target branch should not be a master branch actually. What are the features you merged into the dev branch? Conflict will be occurring here. Upon thorough review and testing, you can update it into your master branch. So the point here is, in the scenario 3, we can allow one developer to work with multiple features. One developer to work with multiple features. What if I want to use the same repository with multiple users, multiple developers in my team? So in that case, it will be considered scenario 4. In scenario 4, what I'm going to do here is, first, based upon the master branch, I'll be having some intermediate branches. And my intention here is to have more than one developers branch. Develop branch 1 and develop branch 2. But we never create this develop branch directly from master. Why? Because if we allow both the developers to directly update the master branch, it will definitely create an impact here. So as part of this scenario, what we do here is we will try to create an integration branch, and this integration branch will be a copy or a replica of your master branch initially. And based upon these integration branches only, your dev branches will be created. So now I have an integration branch, and based upon integration, we have created dev branch 1 and dev branch 2. And based upon this dev branch only, we create the feature branch and feature branch 2 here. So for any developer, we can able to create any number of feature branches, and these feature branches can interact only with the dev branch. So once the feature 1 is ready, they can merge the changes into dev branch 1. And similarly here, once this feature is ready, they can merge into dev branch 2. Once developer 1 has completed the changes, they can able to merge into this particular integration branch now. And it can be considered as developer 1 changes. Similarly, once developer 2 has completed their work, they can able to merge their changes into the integration branch. Developer 2 changes like this. And this is upon merging developer 1 and developer 2. And now once you do a proper review and testing, you can take these changes to the master branch. So here, this master branch can be updated with the integration branch changes upon merging from integration branch. So now the point is, this scenario 4, it is capable to handle a number of developers. More than one developer can able to work on this repository in parallel without impacting the master branch. They can able to make any number of changes and work on it. And at any point of time, once they're done with the feature changes, and if they merge this feature into dev branch, this feature branch can be deleted permanently. If they want, they can create a new feature and work on it. It's a second story. But ultimately, these feature branches, dev branches, all these things can be considered as a temporary branches, shortly branches. And here also, right, I cannot use this strategy at enterprise level. Why? Because at enterprise level, there'll be more than one team, more than one application team might be using the same repository. So in that case, we can further enhance this strategy and come up with a new strategy. So now the point is, I mean, we have a master branch repository. So I have an integration branch, means I can consider this integration branch is for my team 1. This is integration branch 1. And for team 2, I can create another branch, integration branch. So if you look into this workflow here, I have a master branch initially with some commits, CM1, CM2, CM3, right? We have these commits, and based upon these initial 3 commits, we have created one integration branch for team 1 and 2 for team 2. So in each team, they can have their own developers. They can able to create their own features and immediately work on it. If team 1 is ready with the changes, can we directly allow them to update the master branch? Because if both the teams are working on the same file in the target machine, it will impact the integrity of master branch. So what we do here is, before we create the integration branch, in scenario 5, we create a branch called release branch. And that release branch will be a replica of your master initially. So now based upon these release branches, we'll be having your integration branch. So now the point is, any number of teams, they can able to independently work on their features with their developers. And once the developers done with their changes, it will be merged into their own integration branch first. Similarly, the team 2 can able to update the changes in integration branch. Once team 1 and team 2 are ready, they can able to merge their changes into release branch. Like I can say like a team 1 changes. Similarly, team 2 changes. Once my changes are ready in that release branch, I can simply merge it to my master branch as the final level. So in my master branch, I can have something called CM4, and I consider the CM4. 4 is the integration or merge from release branch. So this is how we can able to consolidate all our changes and update your master branch. So at each and every, why we need these many levels means, at each and every level, there'll be a review. I have a feature 2 means it is done by the developer. So here in developer branch, before the feature 2 is merged in developer branch, your application lead or the release person, right, who's responsible for the particular release, he'll be reviewing your changes. Developer change will be reviewed by that reviewer. And once it is okay, then it will be merged to your dev branch. Similarly, from dev branch to integration branch, if you want to merge, there'll be a review. At each and every level, we do a detailed review and then only change will merge to your target branches. So if you consider this scenario 5, it is the strategy that can be implemented at enterprise level. It can be used by any number of teams, any number of developers, and they can able to work on any number of features independently without impacting the master branch. This workflow is meant for a regular release or build cycle. But apart from that, we have one more strategy, that is to handle the production issues. We have something called hotfix branch. So this is promptly used for handle the production issues or bugs. So consider, as a developer, I'm working on this particular release. I'm working on my feature, and there is some unexpected issue in the production environment. I need to immediately give a fix for that. So if I want to fix that production issue which is available in master branch, I cannot take that code into this particular dev branch and create a new feature branch here. It will not work. It will impact the entire, integrity of your branches, because already this team is working on their changes. In between, if you introduce a new thing, it will impact. So what we do here is we create one hotfix branch, and that scenario is something. Consider I have a repository 1, and in the repository I have a master branch with some commits. And now I'm giving you one small scenario here, like I have a dev branch with feature 1 and feature 2. Let's assume this now. So this dev branch initially I created based upon the master branch. And what are changes they're making the feature 1, that is the second thing for now. Okay, I'm not going to consider all those things. As of now, we just created and repositories branches are in sync now. But I make some incremental changes here, something on this feature branch. Now, all of a sudden, there is some production issue. What I can do here is, based on master branch, I can immediately create one feature branch that will not come under the regular build cycle. It is a ad hoc branch. We call it as ad hoc request actually. We create this particular branch based upon the master branch. And in the same branch, we can able to make some hotfix changes. I mean, developer who's working on the particular fix, they will make some immediate changes on the branch. And once they thoroughly test the changes, they can merge it into the master branch. So while merging this, they can simply tag it as CM 3.1. It is not the new release. It is just a fix that is given for the CM3. Already they have committed something on CM3 and they were facing some trouble on CMT3. On top of it, they made some incremental changes, fix the issue, and they just merged it into the target branch as a minor release, something like that. Now, these changes are updated in master branch and it should be synced with your dev branch. That is what another important thing you should consider. Whenever you commit anything from the hotfix branch to master branch, the low branch, that is a dev branch, or if it is a release branch, and even should be updated with the changes. So this workflow will be completely an ad hoc process. Why this has to be updated means then only the feature can able to use the latest changes from the master. Otherwise, this feature will be having its own default CM3 changes with that issues. So like this, we can able to create a number of strategies applicable for your regular release or CR changes, as well as for your ad hoc requirement. So next we'll create branches. So now we'll see how to work on these branches. We'll see how to create a branch, how to merge changes, and if while merging, if there's any conflict occurs, how we can able to handle those conflicts, everything we'll see now. So here in Git, right, there's a command called git branch command. So this is to get the list of branches. And also there is something called git branch followed with branch name. So when you say git branch followed with branch name, it is used to create a branch. Okay. Not only this, there's another command called git switch -c followed with the branch name. So this is also used to create a new branch. And using git switch, you can able to switch to any existing branch. It is possible to switch to a branch. So based on your requirement, you can able to use either git branch command or git switch command to work on your branches. So let me create a new folder here. Test repo 3. I'm going to create and cd to the test repo 3, and let me initialize this. So as soon as we initialize, you can see there is a master branch. And when I say git status, we are on branch master, yet nothing to commit. So what I can do means I can create a new commit here, file 1 dot, or I can simply say like a1 dot text file and add it to staging area of that master branch and then commit this. I can simply say like cm1. Now let me create another file and add it to staging area of master branch and commit it to that master branch. So now if you say git log one line, I can see we have 2 commits in this master branch. And if I say git branch command, you can see it is going to get the list of branches. As of now, we have only one master branch, and the asterisk denotes the current branch where we are now. If you want to create a new branch out of it, you can simply say git branch followed by the branch name like feature 1. So the git branch command will create a new branch, but the control will be there in that current branch, whatever you have used earlier. And if you get the list of branches, you can see we have 2 branches. Out of that, we are in master branch now. So this is one option. And as soon as you create a branch, and if you see the status of the repository, you can see there is no changes. Everything is committed. That means the files, whatever we created, it should be available on both the branches. If I say git log at this point of time, your master branch is in sync with your feature branch. So if you navigate to feature branch also, you will be getting these 2 files there. All right. So this is one method for creating a branch. And apart from that, you can use another command called git switch command, which is very frequently used in latest versions. So git switch -c, C for create a new branch name. So whenever you create any branch, right, ensure that you execute that create command from the current branch or from the source branch which you want to use. My intention is based upon the master branch, I want to create feature 2. So it should be created under this particular branch only. Now, when you say git switch -c followed by the new branch name, it will create a new feature branch and the control will be switched to that branch. See, from master, we just switch to feature 2 branch. And here, if I say git log command, I can see at this point, all these branches are in sync. When I say ls or git ls-files, the files, whatever we create in master branch, it is available in feature branch 2 as well as in feature branch 1. So this is how we create the repositories and we maintain the branches within the repository. At any point of time, if you want to switch to any of the branch, let's say if you want to switch to feature 1, you can switch that, or master, you can able to switch it. So using git switch command, you can able to switch your changes control from one branch to another branch. So this is about creating a branch. Now let me switch to feature 1. And in this feature 1, I can see there are 2 files. Let me create a new commit here. So what I'm going to do here is, we are going to create new commit in feature 1. So let me create new file here. Go record 1. Let it be q1.txt file. Add it to staging area of feature 1 and commit this git commit -m followed by that particular commit message like f1's cm1. I can give like this. So if I say git log followed by that one line option, I can see we have created a new commit for this feature branch 1. It is f1 cm1. So at this point, your feature 1 branch is one step ahead of your master branch. Like this, you can able to create any number of commits. Like I can able to create another commit here in this repo, in this branch. I can able to add to staging area of that branch and commit it to that staging, commit it to that branch. And I can able to check the log here. So now your feature branch is 2 steps ahead of your master branch with these 2 additional files. In the meantime, if I navigate to master and if I say ls, what I can find here, I just came to master branch, and in this master branch, if I say ls, I won't get the changes that we made in feature 2 or feature 1. That's what the parallel development without impacting the target branch. We can able to independently work on it. So any branch you create, it is going to create a logical path, a completely and isolated logical path to maintain your incremental changes. Once the changes are ready, go back to your master or target branch, and in this branch, you can able to get the log and verify the list, everything's here. It is not having any clue about what we did in feature 1. At this point, your master branch and feature 2 are in sync with the initial 2 commits. But feature 1, we made some incremental changes, it's not reflecting master branch. So if you want to bring the changes into master branch, you can use a command git merge command followed by the branch name. So the point is, you can able to create a branch by using git switch -c followed by the branch name feature 1. And in that feature branch, you can able to create a file, make some commits. You can issue git add command and you can able to perform git commit. You can make any number of changes, right? And once the changes are ready, all you should do here is you should switch to master branch, and then you need to issue git merge followed by that branch name feature 1. Why? Because this command, merge command, should be executed from the target. I want to consider master as a target to these new changes. So I just navigated to that master branch, and from that master branch, I'm going to go give a command git merge feature. So now the changes are merged into this branch. And if I say ls, I can able to see the files available. And if I say git log, I can able to see the new changes, whatever we made in feature is available here. So at this point, your master branch and feature branch are in sync. So this is how we can able to perform the parallel development. And before you merge changes into the master branch, we need to do a thorough review in order to prevent conflicts in the target branches. Now I can show one more case here. So let me create a new commit here. So we just made one commit in this repository in master branch. And what we can do here is we can simply go ahead and check the status list. Everything should be fine. Now, let me create a new branch here. Git branch followed by the branch name like feature 1 and another branch called feature 2. So now I have two branches in additional branches here. And all these branches are in sync now with initial commit. Now, my requirement is I want to work in feature 1, git switch feature 1. Once I switch to this branch, I can able to see the same file available with the same content whatever we created, because at this point, your feature 1 is in sync with your master, right? So I just want to add some changes in this file here. So let me create one more record in the same file. Already this file is having one record called record 1. Let me add one more record here. Record 2 from feature 1, file 1.txt. I want to add this as a new record. Sorry. And git add and git commit -m f1 cm1, right? Now, if I say git log, I can see this feature 1 is one step ahead of a master branch. We always compare it with your target branch, okay, like which you want to use for merging. Another thing is, if I say cat command to that file, I can see there is a new record added. Don't worry about the content, just new record has been added to this file. Now I'm ready to merge these changes into the target branch. So what should I do here? First, I should switch to master, and then I can issue git merge followed by the branch name. So the changes whatever we made in the feature branch has been merged into master. That means the file has been updated with the new record here. Now, the point is this master branch has some incremental changes from feature 1. In the meantime, feature 2 also can have some changes, right? If I switch to feature 2 and I can see there is only one record in that file, let me make a new change here. I can add one more record like echo record. I want to add a new record from what is it? Feature 2 to this file. Let me add it to the staging area of feature 2 and commit it to the feature 2 branch. That is F2's CM1. Now feature 2 also ready with the changes, but it has updated the same file and the same record level. Now, if I want to merge these changes into the master branch, what I can do, I can usually go to my master branch and I can issue git merge followed by the branch name. So if I run this command, it is trying to merge these changes from file 1.txt, but it is having conflict. Why? Because already feature 1 has updated that master branch content file with this record. Now feature 2 also wants to introduce a new record in the same position. So whenever more than one feature or more than one user tries to update the same record of the same file, it will create a merge conflict, right? So once merge conflict occurs, you can see the status of repository. It is still in merging state. From master status, it is just showing as a merging. It means there is some integrity issue, data integrity issue here. The file is not properly updated in the master branch. So this is what we called as a merge conflict. So it is a very common scenario that occurs whenever you try to merge the changes from more than one feature into the target branch. So the point is how we are going to work on this, how we are going to handle this. So before you handle this merge conflict, first you need to understand what is merge conflict. So ultimately, merge conflict means whenever more than one user or a feature, more than one feature, try to update the same file, the same record level in the target branch, the merge conflict occurs. And if merge conflict occurs, it is the developers responsible to fix that merge conflict. Then only the target branch can be usable. Otherwise, you cannot use that branch for any sort of integration for further testing. So once merge conflict occurs, how to fix that merge conflict means first you have to identify the file or the file that is causing the issue. And once you identify the file, you have to open the file and review the changes that is causing the issue and decide whose changes has to be retained or removed from that file. And based upon that, you can update the file and update the header and footer tags and save it. Say for example, in my case, first step, I have to identify the file. So while running the command itself, I can able to see the file that is causing the issue. So identifying the impacted file is not a big deal. Git itself will show you the file name here. Or by any chance, if you miss this file name, if you clean up the screen, if you miss that also, you can simply say git status. And you can see, fix the merge conflict and run git command. It is giving a recommendation against this file name. So your very first step, identifying the file is done easily by giving status command. Once you identify the file, you have to open the file and review the changes. Let me get to the file name. When I open the file here, in this master branch, as of now, it is represented like this. We have a very first record. There is no issues because of that record. After that, we have added one new record from feature 1. That was the record available before you merge from feature 2. Now, when you add the new record from feature 2, that is also wants to accommodate on the same record level. So issue with these two records only. So we need to open that file and review the changes that are causing the issues and decide whose changes has to be retained or removed. Whether you want to maintain the feature 1 changes or feature 2 changes, you have to decide. So let me edit the file. All these things we are doing in master branch only. Okay. Now go to insert mode and you have to remove all these header and footer tags. This is something used by Git to maintain the conflicted records. Now you have these two entries. If you want to maintain both the entries, it's fine. You can have it as like this. Or if you want to remove the feature 1 changes, just remove it and save the file. That's it. So that's what the third point. Decide whose changes has to be retained and updated, and accordingly update your file, remove the header and footer tags and save the file. We just saved it now. Upon saving, you have to add and commit changes because your files are not yet committed in the master branch. Okay, if I say git status, it is still in the modified state, unmerged. So you can simply use git add command. We are going to add this new changes to staging of master branch and commit this. I can say like fixed merge conflict. Now you can see as soon as I issue give commit command, the changes are merged. And if I see the cat to the file name, I can see the content and status should be clean now. So this is how we handle the merge conflicts in real-time environment also. It's a completely a manual effort. Okay, it is our developer's responsibility to merge the changes. If any conflict occurs, they have to manually fix those changes. So these merge conflicts and all, right, it is expected where if you're working on your agile methodologies, being in DevOps era, if you are saying that you have implemented DevOps and if you're following DevOps practice means you should not get merge conflict basically. Okay, so because the DevOps approach is not to fix the issue. The objective is to prevent the issue. So as a DevOps resource, you should always think about preventing the merge conflict. Of course, we are the technical people. We know how to fix the issues and all. That is different story. But the DevOps practices, we are not supposed to, get into this situation. Instead of handling the issues, you should smartly think to prevent the issues. So how to prevent the merge conflict? So out of these 5 steps, the very important step that actually, use to prevent the merge conflict is do a proper review changes before merge. Because it's all about the collaboration, right? Developers, they should know what others are doing. If you are working on more than one feature, you should be very clear about what you are developing actually. Because of your change, whether it will create a new conflict in the target or not, you need to be very clear. If the changes are from someone else, you have to interact with them before merge action before you run the merge command, you have to check with other fellow developers to understand what is the actual change, and you need to figure out is there any possible conflicts or not. If there are any possibilities, you have to address it immediately before merging so that it will not create any conflict in the target environment. That is what team build, team collaboration is very much important here. Now, this is all about handling your conflicts as per the process. Okay, preventing issues, it's all DevOps process. Okay, so it's a process based approach, but it is not like, we are going to, rely on other technical issues. Okay, so as per the DevOps process, we recommend people to make it more collaborative effort and review the changes before you merge in the target branch. Whatever the strategy you're following, before you merge anything to a target, just have a detailed review and merge it so that it won't create any conflict in the target environment. So this is about the process. But apart from that, Git also provides some features to handle these changes. So there is something called Git Rebase and there is something called Git Squash. So these are the two important, options or commands used as part of your merge action. So it is always recommended to use Git Rebase before you merge anything to target branch. It is a best practice actually. So what is the need for Git Rebase means? Basically, it is used to keep the current branch in sync with the target branch. And it also helps to maintain the linear commit history, and it is ultimately used to prevent the merge conflict in the target branch. And as a best practice, we always recommend to use Rebase. Consider I have a repo with a master branch. So now if I create a feature branch here, it will be a copy of a master branch by default, and it can be for feature 2 also, it is applicable. Now, in this feature branch, if I try to make any incremental changes, something like this, these changes will be merged into your master branch. So what I can do upon making changes, what I'll do here, I'll just give git switch to master, and from that master branch, I can able issue git merge feature 1. So once I run this command, your master branch will get updated with the latest changes from feature branch. Feature 2 also will be having some incremental changes. So now how these feature 2 is going to get merged in target branch? If I simply use this command, what happens, the changes whatever you made, it'll get updated in the master branch. And in master branch, what are things you made from the feature 1, it'll get aligned at the end. This is upon merging feature 2 without proper rebase. So if you look into the commit history here, the expected commit history is something like this. This is the expected one. Before you bring the changes from feature 2, already the master branch got updated from feature 1. So in master branch, this is a commit history, CM1, and then we have feature 1 changes. Now, when you introduce the feature 2 changes, feature 2 is not having any clue about what happened in the master branch. It is still considering the first 3 commits as the initial commit as a baseline. So on that baseline only, it will try to update the new changes, and the inclusions whatever we made in that master branch, it'll get added at the end, align automatically at the end. So this is something creating an impact in the commit history. So the solution here is always your commit history should be linear, it should be in sequential manner. So whenever you try to perform any merge action, just before the merge, you can simply use a command git rebase master. Once you're done with your changes, just issue a command git rebase command followed by that target branch name, and then switch to master branch and merge it. So now when you issue git rebase master, what happens, the latest changes from the master branch will get updated in your feature branch like this. Now it will consider this as a new base. When you create feature 2, this was the base, and now we are just changing the base to the latest commit from the master. So after rebasing, your new incremental changes, what we made in the feature branch, will get aligned like this. And now when you issue git switch and merge, these changes will get updated in your master branch like this. So git rebase helps to maintain the linear commit history. And another important thing is, while you're rebasing the changes, means You are trying to bring the changes from feature 1 into feature 2 through master branch. While doing this, if there is any conflict occurs, it is going to impact the feature 2 only. If the feature 1 is already updated a file and the feature 2 also updating the same file, means definitely you can face the merge conflict. But here the merge conflict will occur in the feature branch, not in the master branch. That's why using rebase, we can prevent the merge conflict in the target branch. Got it? Even if it occurs, it is not going to impact your target branch at any point of time. That's the reason it is always recommended to use rebase before merge. Let's create a new folder. Git init. And now, so let me create a new commit here. Go record. So now we are trying to update this changes in the file. So let's create a new branch, git branch feature 1 and feature 2. I have created 2 branches here, and if I say git log, I can see all these branches are in sync with these 2 files. Now let me switch to feature 1. Git switch feature 1. And here, let me create a new file. Git, sorry, go record 1 w1.txt, git add and git commit to that repository. That is f1 cm1. Similarly, let's create few more commits. We have created one file, right? w1.txt file, and the status is clean, right? Okay, let me create another file, w2.txt, git add, and then git commit f1's cm2. Creating another file, adding to staging area, and then committing it. Now, if I say git log 1 line, I can see my feature branch 1 is 3 steps ahead of my master branch. So as I said already, it is always recommended to execute your rebase command before merge. Now I'm ready with the changes. If I say git rebase, followed by the target branch name, at this point, your current branch, feature 1 is up to date with the target branch, because the target branch is still having these 2 commits. It's not having any other incremental changes from any other branch. So what you can do, you can simply say git switch to master and git merge followed by the branch name, feature 1. Now all these new files are available in master branch, and also if you see the status and the log, you can able to see your current branch, master branch, it is in sync with your feature branch 1, and the commit history is maintained in a linear fashion with this basic thing. In the meantime, let's get into this feature 2 and let's create new files here, or new commit as per the need. If you see the commit history here, it is not having any clue about these 3 things. The new changes, whatever we done here, it is not having any clue about it. So what you can do, you can able to make some commits. Go to staging area and then commit it. Let it be F2, okay, no problem. And let it be like E2, add it to staging area and then commit it. Again, I'm creating another file, adding into staging area, and I'm going to, create a new commit point. Like this, we can able to make some incremental changes in this feature 2 branch. And now if I say git log 1 liner, I can see my feature 2 is having some number of commits. We made some new commits in the feature 2 branch, but it is not having any reference of your master or feature 1. So if I'm ready with my changes, before I merge into the target branch, what I can do here is I can simply use git rebase master. So now it is successfully rebased and updated the head pointer reference of this feature 2. And if I say the log here, you can see the changes. Earlier, it was having the incremental changes on top of the initial 2 commits. Now it has been realigned. Your new changes, whatever you made, it is aligned on top of the latest change from the master branch. So this is what the linear commit history as per the status. And now you can switch to git switch to master and perform git merge from feature 2. That's it. So now all the changes are available. And at this point, if you say git log 1 line, I can see your master branch and the feature 2 are in sync, because the feature 1 is not having any clue about what we did in master branch now. The latest change from feature 2 is not updating feature 1. If you want, what you can do here is you can go to your master feature branch, git switch to feature 1, git switch to feature 1. And if you say git log one line here, you can see the initial comments, whatever we made in the feature 1, which was up to date with master, but now the master is in sync with feature 2. So what you can do here is, as a best practice, you can simply say rebase. If you want to bring the incremental changes from the master branch into the current branch, you can able to use git rebase at any point of time. Now your branches are in sync. So it is always recommended to use git rebase in order to keep your current branch in sync with your target branch. The next important thing is about git squash. So this git squash is not a command, basically. It is an option for merging. So it is used to combine more than one commits into a single commit point. That's it. Say for an example here, while merging the changes, we use a command called git merge along with this squash option. It is an option that helps to combine more than one commits into a single commit point. Say for an example, consider I have a repository with a master branch and a few commits. Okay, we have these 3 commits here. Yes, conflict will occur. That is not an issue. But using rebase, we can prevent it in the target branch. That is the point. While rebasing, the conflict will occur in the target branch, into which branch you are merging, right? In feature 1 or in feature 2, definitely you'll get a conflict if you update the same file. But it will not impact your master branch. So before you merge, you have to fix that issue and merge it. That's it. So whenever you get many merge conflict, fix the merge conflict and then merge it to your master branch. Now, the next option is, while merging changes, you can able to combine the commits. Let's say I have a master branch and I have created a feature branch here. So upon creating a feature branch, I can able to create a number of commits. So developers create hundreds of commits in their branch because they are doing some code changes, they're developing some functions till they get the result, successful result. They'll be keep on updating the branches with a number of commits. There is no limitations and we can't restrict that also. But we can give some best practices to follow. That is second story. But by default, developers are allowed to make a number of commits. So once developer make these many commits, and if they simply merge changes to target branch, what happens? Git switch master. And then if they give the target branch name while merging, what happens means all these commits, whatever they made, everything will get dumped into the master branch. But it is not mandatory that you have to expose all your commit history to the target branch all the time. There are some scenarios you can expose it. Otherwise, you can simply combine all these commits into a single commit point and update it. So to do that, you need to use a command option, git merge ---- squash followed by the branch name. So when you run this command, right, it will update your incremental changes from feature 1 into the staging area of a master branch, and it will wait for your response to commit. While committing, just give one commit message. It just creates one new commit point there with the latest changes. That's it. So for an example here, in this case itself, we are on this feature branch and I think it is in sync now. Okay, let me switch to master, or we can make some commit here itself, no problem. L1.text add to staging area of feature 1 and git commit L1 CM1. Okay, some changes like this. I can able to make any number of changes. I'm keep on adding a number of changes in the feature branch, and I have created nearly 5 files, new files here, starting with L. And if I say git status, it should be clean. And if I say git log one line, I can see my feature branches 5 commits ahead of my master branch. Now I am ready with the changes. So I want to merge it to my master. So while merging, what I'll do, I will try to switch to that branch, git switch master. And from that master branch, I can simply say git merge followed by the branch name. If I use this simple git merge command with a branch name, it will try to dump all these commit history into the target branch. but I don't want to expose all these commit history. So what I can do, I can use an option called squash option here. Squash is an option to your merge. So when you execute a merge command with squash option here, it will add your changes into the staging area of a master branch. If you say git status, you can understand it. Once the changes are in staging area, you can use git commit command -m, give a commit message like combined changes of L1 commits. That's it. Now, if I get the status of the repository, it is clean. And if I check the log, I can see it has combined all these 5 commits into one commit point. All right, just on top of this F2 CM4, we were having 5 commits. Now it is just one commit point. It is not going to impact the data. The files, whatever you created, it will be there as it is. You can able to access the changes in the master branch. But only thing is the commit history will get updated with the combined entry. That's it. So it happens, okay, it is must to have in real-time environment. Why? Because we'll be working on multiple scenarios. It is not always required to expose all the commit histories into target branch. You don't need to dump all the commits into target branch. You can consider this example itself. While working on these scenarios, if you noticed here, consider scenario 4 or 5. So in scenario 5, based upon the master branch, we have created release branch, and we have some integration branches, develop branches, and then feature branches. So if you look into this particular workflow for this integrated branch alone, these feature branches are going to have some incremental changes. Developers are going to actually work on it. And once the changes are ready, it has to be merged into the dev branch. And in dev branch, as a reviewer, I have to do a detailed review. So in order to perform detailed review, I need all the commit history from the feature branch to be updated in dev branch. That is the reason you can see your feature developer branch is updated with all the commit points of feature 1 and feature 2 at every level. Now, in my dev branch, I'll be doing a thorough review and testing. And upon review, I'll be merging this dev branch 2 changes into the integration branch. Now, while merging these changes into integration branch, do you still need all these commit histories in integration branch? It's already reviewed, right? Do you still need that? It's not required. So that is the reason what I did. I just consolidated. I just combined all the incremental commits from the dev branch and create one new commit point called developer 1 changes. Similarly, the developer 2 changes. So it is a combination, combined changes of feature 1 and feature 2. This is what we call as squashing. Similarly, from integration branch, if you merge into the release branch, what I did here, I've just integrated the developer 1 changes and developer changes from integration 1 and committed as team 1 changes. I'm not going to dump these 2 commit points there. Similarly, we have combined the changes from dev 1 and dev 2 from integration branch 2 and create a new commit point called team 2. Now, once the changes are ready from both the teams, I'm going to merge the changes from these 2 teams into the master branch. For that, I'm going to create one new commit point called CM4. It is a merge from release branch. So here also, we're not going to dump everything. We're just creating only one commit point. So just try to understand the flow, okay? Like in your low branches, in your development branch or in your feature branch, you can have n number of commits. But all these commits should not get dumped into your master branch. Your master branch, if you're working for a particular release, means it can be having one commit ID for the release. That's it. You should always keep your master branch as clean as possible, without any impacts, without any conflicts, without any junk commit histories. So as a best practice, use your Git rebase to keep your branches in sync. And while merging, if you don't want to expose your merge history, you can simply go ahead and define your squash option while merging. So this is what we use while merging. And there is another advantage also. Sometimes what happens, while working in a real-time environment, consider a scenario in a real-time case, right? I consider I'm going to work for a particular release. I'm working for this particular October or November release. I don't think it's possible because already it's a freeze period. So anyways, so consider we are just working on for a particular release. And now in this case, if I want to accept the changes only from team 1, both team 1 and team 2 are ready for the changes. Both the changes are available in release branch. But due to some reason, I don't want to take team 1 for this particular release, current release. So how I can able to pick up only this particular team 2 changes in the target branch? For that, we use one concept called cherry pick. So this git cherry pick also it is same as like a merge, but difference is it is used to merge specific commit to the target branch. It means in my release branch, consider I have team 1 changes and team 2 changes. If I say git cherry pick followed by that commit ID, only that particular commit will be merged into your target branch. Easy. So you can simply refer it as git cherry pick followed by team. Assume that it is a commit ID changes. Only the team 1 changes. Which team changes you want to move to your target branch. Only that changes can be picked up using cherry pick option and merged in target branch. Using cherry pick, we can achieve that. But one important point here is, as a best practice, git cherry pick is not recommended to use. Okay, it is not recommended to use cherry pick. Even in real-time environment, when we train our resources, when we ask developers also, we never highlight all these features. We never expect the developers to use this cherry pick. Why? Because if you want to use cherry pick, you should strictly follow git squashing. Without proper squash option, if you merge your changes to the target branch, means in that case, it is not recommended to use git cherry pick. Why? Because let's say consider the same scenario here. In this scenario 5, I have two teams. Assume that without squash option, if I use a simple merge, what happens? This entire feature 1 and feature 2 commit history will be dumped into the dev branch 1 and dev branch 2. And again, all these commit history will be dumped into your integration branch. And from integration 1 and 2, it'll get dumped into the release branch. And again, it'll get dumped into the master branch. Now, if the release branch is dumped with all these commit histories, and it will be like a huge list. There'll be hundreds of commit points updated in the release branch, right? Out of that, how can you choose team 1's commit point? Is that easy? Is it easy to choose only the team 1's commit history from that huge list of commits? Definitely not possible. Even if you miss one commit also, it will create a huge impact. So that is the reason we never encourage people to use cherry pick in real-time environment. Easy? So that's all about your Git branching and other stuff. So in the next session, we'll be focusing on our another important topic in Git stash, and we'll see how to work with your Git remote repositories. That is your GitHub.